So first of all, a disclaimer: my neighbors decided to have a party tonight, so I hope it's not too noisy for you. If it is, then I apologize. So hi, I'm Antonio. I've been working together with GerritForge for the last couple of years, and today I'm going to talk about an overview of Gerrit in AWS. In the previous summit, Luca already gave a talk about Gerrit in AWS, but it was more kind of like a high view talk about the journey that Gerrit in AWS is doing and why we are kind of like tackling this this project. This talk is going to have a little bit of a different take. It's going to be a little bit more say detailed, and I'm going to show you a little bit of features, and I'm going to give you a little bit of details. So I'm going to talk about what actually is AWS-Gerrit project. We're going to go through an architectural overview so you can actually understand what is available with the project. And then I'm going to showcase some main features with a particular attention to the latest addition to the family, which is a demo on Xray. And I'm going to tell you what that is. So what is AWS-Gerrit? So AWS-Gerrit is a collection of templates that we use to deploy, monitor, and maintain Gerrit in AWS. We mainly use a CloudFormation template to do so. And CloudFormation is a AWS service which allows to create a collection of related AWS resources and to provision them to AWS in a predictable way. So Gerrit AWS comes with different flavors. We actually call different architectural solutions, we call them recipes. And I'm going to show you more of this later. And supports creation from scratch. So in order to deploy Gerrit to AWS, you don't need anything in particular. You can just deploy from scratch, and you will have a Gerrit installation, which may be even fairly complex in the cloud. We support blue-green deployments, so once you deploy your Gerrit in AWS, you can evolve it and upgrade it without actually having any downtime, which is a good feature to have. It's highly configurable. The way it is configured is by setting up a .env-like file, which you can then configure depending on your needs. There are many hubs to turn. However, we provide some sensible configurations, default configuration for all of them. So you should be able to deploy AWS to the cloud without too much fiddling, and you should have something working very fast, and then you can kind of like iterate to tailor it to your needs. So why is it useful to have Gerrit in AWS? What is this project all about? And we believe it can provide a blueprint for best practices to companies that already have installations of Gerrit in AWS. Like many companies have at least part of their infrastructure in AWS. Maybe Gerrit is not yet part of that infrastructure, or maybe Gerrit already is part of that infrastructure. And in both cases, it is useful to kind of like provide a set of best practices that we believe should be followed when deploying Gerrit in AWS, such as deploying something that can be scaled, that can be observed. We try to follow like well-architected principles for which we can deploy AWS Gerrit in a way that is secure and it follows some good principles. You also get the benefit of creating repeatable environments, which obviously is a nice property to have, because you will be able to very quickly create dev environment and staging environment that actually can even they're always going to be the same, so they're going to allow you to do some proper testing that actually can have some consistent and repeatable results. In fact, we are already using AWS-Gerrit to perform some the testing of release candidates and stable branches for Gerrit releases. In the Gerrit CI Jenkins job, we have a job that actually deploys the Gerrit to AWS, and then you run some Gatling tests against it. And we can use that to validate feature and performance. So overall, it can give you the ability to run some quick experiments on something that is a little bit more complex than just spinning up a Gerrit Docker container and on your instance. In fact, we found this to be very useful in many occasions. Like recently, we've been chasing a bug that was only manifesting itself on JGit when data was on an NFS file system, and it was very convenient to deploy AWS to the cloud and actually have a complex setup in which we had a multi-master Gerrit installation that was sharing data over an NFS. It would have been more complicated to kind of like set up that from scratch. So I was planning to go through the available recipes that at the moment are part of the AWS-Gerrit project, and then we can kind of like look at them together. And then in my demo, I'm going to show you one particular of these recipes. I'm going to go from the most simple to the kind of like the most complex. And so we start from this very complex graph, which basically, so this is the simplest recipe that we have available. You can deploy a single primary Gerrit instance, which basically is just one single instance sitting behind a load balancer. So every recipe is kind of different from each other in terms of what components are actually deployed, but there is like underlying set of features that we always deploy. For example, all Gerrit instances will be deployed as part of auto-scaling groups that can allow to scale the number of instances up and down, and I'm going to talk about this later. But also they act as some sort of supervisor for which, like, even in this recipe, if you deploy a single primary Gerrit in an auto-scaling group and that Gerrit dies for any reason, the container process exits, then the auto-scaling group will bring back that instance up and running. We deploy Gerrit always as Docker containers, which on a system which is called ECS, which is the Elastic Container Service, which basically is the container orchestrator on AWS. And all the recipes also get monitoring out of the box, and I will show you more of this later. So this recipe that you see now is actually the one that we are currently using for testing release candidates. So we deploy a single primary instance to AWS, and then we run Gatling tests against it. And now we're working on kind of like making this a bit more sophisticated, where we will actually deploy a dual primary instance, which I'm going to show you later. So we have some results on Gerrit with a more complex architecture. So this is the evolution of that architecture, which is basically similar, but now you will see actually you actually see the introduction of the load balancer with some replicas behind it. So the replication between the primary instance and the replicas happens via replication using the replication plugin. We are currently working in integrating pull replication as well. Martin spoke at length about many reasons why we think this is a good idea, and so we are actually making AWS-Gerrit up to speed with that concept, so that we can leverage pull replication. And then we go from here. We can you can also deploy the dual primary recipe. This is a highly available environment in which you have two primary Gerrit instances behind the load balancer that are serving traffic in an active way. So they share Git data over EFS, which is the AWS managed NFS basically, and they make sure to avoid split brain by basically checking the ref database, so that when a request a write request is received by Gerrit, it will first check its validity against the ref database. But I will show you more of this later when I give you the demo. I will show you also DynamoDB and how it behaves. So this is the most complex architectural package that we have, but you can also kind of like get a little bit more complex than that by actually using it in a multi-site deployment, in which basically you get each one. So that deployment becomes one of the available sites, and you can actually deploy the highly available environment in multiple regions in AWS, and each one of those will just act as a different site. They communicate to each other by sharing data and indexing and cache evictions and Gerrit events by communicating on some sort of stream, data stream pipeline. At the moment, we support Kinesis, obviously this being AWS, but we also support Kafka and gcloud PubSub, for which we have provided implementations in the plugin implementations that you can just install and leverage. The cool thing about this deployment is you can also get to deploy a Route 53 DNS in front of it that is able to do geolocation routing to the different sites. So developers will be automatically routed to the closest site to them, and the DNS can also perform health checks, so that if one of those sites becomes unavailable for some reason, either because of he went into split brain or he had some infrastructural issue, then his health check will fail, and at the DNS level, it will be automatically routed to the closest site available. All of this is part of multi-site project, so if you don't know about that, you should check the multi-site plugin. There is a very good design documentation that will enlighten you about this approach and the reasons behind it. Yeah, so this is just a list of some of the key features, and I'm going to show you most of those in my demo. Basically, you, as I mentioned before, you get a CloudWatch metric dashboard out of the box. We actually implemented a CloudWatch metric reporter plugin that will export metrics from Gerrit to AWS, and we pre-package a nice dashboard for you to start with that you will get automatically as soon as you deploy Gerrit to AWS as a sort of starting point. So my graphs weren't really very complete because I always draw one load balancer that was facing Gerrit instances, but actually we always deploy two load balancers. So in fact, one of those always works at TCP level. So basically it does the load balancing of SSH requests really. And then there is another load balancer which is dedicated to HTTP, which works at level 7, and so it does application load balancing. And it has visibility on the entire HTTP request going to Gerrit, allowing to do very nice things such as like sharding based on the URL path rather than the client IP. Or you can also get cookie-based sticky sessions, so you can route some users to one Gerrit instance and some other to another Gerrit instance, and all of this is very easily configurable. You can deploy from snapshots. This is really cool if you want, for example, to get production data. You want to create a staging environment which is based off it. You can get auto scaling of replicas, which means that you can configure AWS-Gerrit so that you can specify for which criteria you want to enable auto-scaling. So you can say things like, if the average CPU usage of my replica auto-scaling group goes over, say, 75%, 80%, I want the auto-scaling group, I want replicas to increase their size by 30%. So it allows you to respond quickly to peaks of demands from, say, Jenkins jobs or for developer users. You get maintenance jobs. For example, you can run GC, which we execute as a scheduled container that will pop up, run the GC, and then die on a cron job manner. And then, as I mentioned before, the latest introduction is the Xray, which I'm gonna talk about later. Here we have checked out the AWS-Gerrit dual primary recipe, and we're just going to run a make command and we specify some basic variables, for example, the name of the stack that we want to create and the version of Gerrit. So we are deploying a 3.3.6. We hit the create all command, and we will, so what this is doing now is uploading a bunch of CloudFormation templates to the cloud, in particular to AWS S3. And then is building some Docker images. So he's downloading the relevant plugins that we want to get running, and then he's building some Docker instances. Once this is done, then we can head to the CloudFormation section in AWS, and we can see that the stacks are being created. So the create is in progress. This will take, it depends on some factors, some configurations, but it might take 10 minutes, 15 minutes, at the end of which you will have all the components that are relevant for this particular recipe created. And this is the Gerrit instance that has been created. So this is its name, demo3 HTTP, primary is Gerrit demo. You can sign in. So everything just works out of the box. Because, as I said, you can deploy from pre-existing snapshots. So this particular instance that I deployed already comes from with a demo project that I created from a snapshot, and we're gonna create some traffic that against the project. So we're going to create some changes, and we're going to leverage some REST API calls using Gatling. So we are targeting that project, and we are targeting that Gerrit instance with Gatling, which, if you don't know what it is a set of tests that is able to test both at Git and HTTP level. So we run make run, not make ruin. And this is going to start a simulation that creates basically changes. So as we refresh Gerrit now, you will see the changes started to come in. So now we are basically simulating users using our Gerrit instance. And this is the sort of change that we create. We just create some random content for some random commit. And now, because we are creating changes, I can show you things moving a little bit. So DynamoDB is, just as a reminder, that we deployed a dual primary recipe. So we have an active Gerrit instance. They are sharing a ref database in order to understand what is the latest version of a particular ref. So I'm gonna show you now which tables are available. So there are two tables available. One is the refdb table, and the other one is the log table. So the way it works is that when a write is received by one of those Gerrit instances, it will first acquire a lock on the log table. It will then go to the refdb table, and it will check for the current SHA-1 value associated with the specific ref that is being updated. And it will make sure that its view on that ref is actually up to date. So it will do a compare input operation, basically. If the ref will be updated only if the current ref value is the expected one. Otherwise, the write will be rejected and the error will bubble up to the client. If the write is accepted, then DynamoDB is updated, and then the lock on the DynamoDB lock table is released. So here you can see the list of refs that are being updated as we create changes with Kotlin. Because we are creating traffic, now you will be able to see that actually there is a dashboard that is created out of the box, which takes the name of the stack that we created, in this case, demo 03. And this is actually showing you some basic set of graphs. So the classic ones, you have CPU load, system load, use memory, GC time, and then you have some application specific, some kind of like the scheduled task queues. And this is just a very minimal set of graphs that can get you started. But the point I was making earlier is that actually you have available all the metrics that you would normally have available in Gerrit. So if we look for the entire list of metrics by browsing them here, you will see the familiar metrics that you might have seen before when you were setting up your Grafana dashboard, for example. And you can add any of these to your dashboard, that you will immediately to see the results of those graphs. So it's actually a quite easy way to set up your monitoring. And lastly, I'm going to show you Xray a little bit. So when you click on Xray, the first thing that is going to happen is the computation of a service map. So I need to explain a little bit what Xray is, so that you can follow me through in this presentation. And basically, Xray is a service that allows you to visualize and troubleshoot performance and problems in your distributed application. In this particular case, our dear Gerrit deployment. And the way it works is that when a client is making a request to Gerrit, that HTTP request will go through a load balancer, which will attach a header to the HTTP request. And then as that request goes through different parts of your system, each part of the system will attach a subsegment to the same header. This trace information will then be sent to an Xray agent that we deploy alongside Gerrit. And I should say that all of this is achieved without changing any code in Gerrit. So there is no coding involved in this, but this is just achieved by instrumenting the Java application with a special Java Xray agent, basically, which will take care of doing the sending to the Xray daemon. So it's actually a really not invasive solution, and it provides a way to actually have visibility on the topology of your distributed application. And a nice feature of this is that because out of the box, you can also get instrumentation of any JDBC connection. And we are using JDBC drivers to actually connect to our H2 caches. Then you also have visibility on every H2 cache that you are using, the Gerrit is using under the hood. So you have visibility on the very familiar mergeability cache and diff cache and etc. You can see the latency and the number of requests for those. So if there was a bottleneck for one of the caches, or if you could see that one cache was like massively underused, for example, you would be able to see this immediately by looking at the topology. So each node of this graph is a component of your system, and there is an edge connecting those two nodes if there is some sort of communication, whether it is an HTTP communication or whether it is a JDBC connection. So now that you see this, you will be able to remember the architecture that I showed you before, where we actually have one primary Gerrit and another primary Gerrit, which are connected to each other by the high availability plugin that keep each other up to date. And each one of those is also updating their relevant caches and the two DynamoDB tables that I just showed you. So by looking at these, you can also get to have different view. You can click on health and actually see immediately which nodes are healthier than others. So the more error, the smaller the node will be. And you can also see the traffic distribution. So if you click on the traffic section, you will immediately see, depending on the size, it will be kind of easy to understand if the load balancing is somehow off, right? If you see one of the two Gerrit instances, for example, receiving massively less traffic than the other, then you will, at a glance, you will know that there is something going on with the load balancing. So another thing you can do, you can check the type of the components. So you can overlay these icons on top of your components, and you will see which SQL databases you have, as opposed to ECS services, as opposed to DynamoDB tables. You can also drill into the all the connections that goes through one node. For example, if we click on the primary 2 node, we can immediately go and look at all the errors that are related to that node. So for example, we can see all the traces that somehow generated an error. We can then, for example, use a group by to group them by status code, and you immediately see that 96% of the errors we received so far is to do with permissions, because we're getting a 403. And you can see that all of those permissions are to do with the Gatling test. You can also click on an edge, which will show you all the connections that are kind of like somehow involve the communication between primary 1 Gerrit and primary 2. So by clicking on the edge, you are filtering the view of the request to only the ones that are involving those two nodes. And then based on that edge, you can do some additional filtering on them. So for example, you can ask for all the requests that lasted for more than 100 milliseconds that somehow involved those two nodes. And when you see the results, you can then drill into the results, and you can see, for example, that in the breakdown of the segments, you will see that the communication with the secondary node actually took 116 milliseconds. So that fulfilled the query that we just executed. And you also see the graph of that specific communication path. You can also run filtering at generic level. So you can ask, for example, for all the requests that contains a received pack. So now we're gonna look at all the requests, all the writes basically to Gerrit that happened so far. And then you can click on each single request, and you can follow the breakdown of that request through your system. And you see here, for example, that the primary one received the received pack. And then, as you remember from my explanation, we then went on the DynamoDB lock table, we acquired the lock. And then after acquiring the lock, we updated the item, as I said before, for the write. And then we released the lock. You can see this delete item is releasing the lock after the write. So at that point, the write was successful. So that means that now Gerrit can update its caches. And that's why here you see an update to the diff summary and the mergeability cache. And after the caches have been updated, you will see the remote call to the other node for the high availability endpoint. So these are the cache eviction, ref scheduled, and ref replication done calls to keep each node up to date. You actually have a quite sophisticated set of queries that you can run that will easily allow you to understand better the behavior and the performance of your application. Yeah, we didn't have enough time to cover all of them.